Hello everyone, welcome to our channel Brenu Academy. So in this video, I have started a new lecture on a new chapter named Nuclei. In this chapter, in this today class, we are going to start atomic number and mass number. So in chemistry, while studying so many times, we have been asking the atomic number for so many elements. So, for example, for nitrogen, the atomic number is 7. For oxygen, the atomic number is 8. For fluorine, atomic number is 9. And for helium, the atomic number is 2. And while studying in chemistry, we have been said so many times that the atomic number is a characteristic property of an element. Right? It is a characteristic property, is the main property, is the main feature of the atomic, like of an element. Atomic number is the major feature in the element. So what actually the atomic number is? How we are saying number 7 is the element nitrogen. How we are saying the number 8 is the element oxygen. So on what basis we are saying that the atomic number of an oxygen is 8, the nitrogen is 7? Is there any reason for this? Yeah, of course there is a reason. The reason we will study in today's lecture. So now I am starting with atomic number. So before proceeding to the atomic number, we are going to see the subatomic particles of an atom. Yeah. So, as you know already, the subatomic particles of an atom are proton, electron, and neutron. These three are the subatomic particles of an atom. And now I'm going to give you the mass of a single proton. So mass of a single proton is equal to 1.6726 into 10 to the power minus 27 kilogram. Mass of the electron is equal to 9.1 into 10 to the power minus 31 kg. Mass of the neutron is equal to 1.6750, or in some textbooks it has been also given as 49 into 10 to the power minus 27 kg. Kilogram. Kg is the unit of mass, it is kilogram. Yeah. So why I introduced the mass of the subatomic particles? What is the reason for the introduction of the mass of those subatomic particles of an atom? So the main reason is that is a statement given that the entire mass, the entire mass of an atom is concentrated entire mass of an atom is concentrated in a small volume at the center of an atom named nucleus. At the center of atom named nucleus. So you can say here entire mass of an atom is concentrated at a small volume at the center of atom named nucleus. For example, if it is the atom, at the center a small volume is present which is known as nucleus. It is the nucleus, and the entire mass is concentrated at the center of an atom. So why I am saying the entire mass is concentrated at a center? What is the reason for it? Yeah, as you know already, inside the nucleus, if I can remove it, yeah, inside the nucleus, if I am speaking about inside the nucleus, I am going inside the atom. I am going inside the atom, I am going inside the nucleus. Right? As I am going inside the nucleus, there are two subatomic particles present, and those two subatomic particles are, one is the proton and second is the neutron. These proton and neutron are those two subatomic particles which is present inside the nucleus. And outside the nucleus, you can see the electron is revolving. So outside the nucleus, the electron is revolving in an orbit. Right? As you know, this electron is revolving in an orbit outside the nucleus. So outside the nucleus, you can see the electron. Right? So if I'm speaking about the mass of an atom, then I should have to write mass of the atom is equal to mass of the proton plus mass of the neutron plus mass of the electron. Right? Mass of the proton plus mass of the neutron plus mass of the electron. So here, as you can see, it is the mass of the proton and it is the mass of the electron. If I am comparing these two masses, I am getting a number. Mass of the proton is equal to 1837 times of the mass of electron. Right? This number is very important. Right? So mass of the proton is equal to 1837 times of mass of the electron. That means it is 1837 times it is greater than the mass of the electron. So when compared to the mass of the proton, this mass of the electron is very less. So it is nearly negligible. For example, if I can write here the mass of the electron, where I can write is that, yeah, I can write here mass of the electron is equal to mass of the proton upon 1837 times. Right? So here mass of the electron is 1837 times lesser than the mass of the proton. So when compared to a single proton mass, the electron mass is negligible. That is why whenever we are considering the entire mass of an atom, we are just considering the mass of the nucleus. We are only considering the mass of the proton and mass of the neutrons. We are not considering the mass of the electron. This mass of the electron is nearly negligible while calculating the mass of an atom. So whenever we are going to calculate the mass of an atom, at the time specifically we are ignoring the mass of the electron. We are ignoring the mass of the electron. We are just because it is very lesser mass when compared to the proton and neutron mass. So as you can see here, that means mass of the electron has been removed. Yeah. Now my question is that these two subatomic particles are present where? It is present inside the nucleus. It is present inside the nucleus. As you can see, as it is present inside the nucleus, I can even write the mass of the atom is nothing but the mass of the nucleus. Mass of the nucleus. So mass of the atom is nothing but mass of nucleus. And what are those two subatomic particles present inside the nucleus? Proton and neutron are those two subatomic particles which is present inside the nucleus. So if we are able to calculate the mass of the proton and the mass of the neutron, we will be able to get the total mass of an atom. Right. So before understanding the concept of atomic number and the mass number, it's very necessary that I should have to make sure that you should have to understand the mass of an atom and some concept of the atoms. Right? So as you can see here, you now understood what are the subatomic particles present inside the atom, What are those three subatomic particles? Those three subatomic particles which is present inside the atom is nothing but protons, electrons and neutrons. And even we came to know that entire mass of an atom is concentrated at a very small volume called nucleus, which is present at the center of an atom. Yeah. Now, as you can see, it's a nuclei. So we are just going to deal everything with protons and neutrons, because inside the nucleus only two subatomic particles are present, that is proton and neutrons. So now I'm going to introduce our first concept, that is atomic number. Yeah, this is our first concept what we are going to study, atomic number. So how we are saying for the nitrogen the atomic number is 7, how we are saying that the atomic number for the helium is 2. What is the reason behind it? Now we are going to learn that one in this video. So atomic number of protons present inside the nucleus is known as atomic number. So as you can see, number of protons present inside the nucleus. So we now came to know what is atomic number. Atomic number is nothing but we are going inside the atom. We are going at the small volume known as nucleus. Inside the nucleus we are entering into the nucleus and we are counting the number of protons inside the nucleus. If once we came to know how much number of protons is present inside, we can say that is only known as atomic number. So atomic number is nothing but number of protons present inside the nucleus is only known as atomic number. So number of protons present inside the nucleus. If I am saying the nitrogen atomic number is 7, that means I am entering inside the nucleus. I am seeing there are 7 protons is present. If 7 protons are present inside the nucleus, then the element is nitrogen. If 8 protons are present inside the nucleus, then the element is oxygen. So it is the atomic number which is going to decide the element. So atomic number, it is a characteristic feature of an element. It is a characteristic feature. It is a characteristic feature or property of an element. It is the characteristic property of an element. If I am saying it is 7 protons, then for sure it is the nitrogen atom I am speaking about. If I am saying only 2 protons are present inside the nucleus, then it is the only helium atom which I am speaking about, because it is the characteristic feature. If once I am saying that only 3 protons are present, that means it is a lithium, because it is a characteristic property of an element. It is only going to decide, if the number of protons is only going to decide what element you are speaking about. If it is a number 9, that means you are speaking about the fluorine atom. If it is a number 18, that means you are speaking about the argon. Right? It is the inert atom, as you know already. Right? So it is what atomic number. And what is the representation? What is the representation to represent the atomic number? How to denote the atomic number? We denote the atomic number as Z. Right? It is a symbol to denote the atomic number, or you can say it is a representation to denote the atomic number. So now we are moving towards mass number, our second topic. So here you came to know what actually the atomic number is. Now whenever you are going to study in chemistry. Like I'm speaking about nitrogen or I'm speaking about sodium, we are saying that the atomic number is 11. So you should have to know why we are saying the atomic number is 11. We are going inside the atom, we are going inside the nucleus. I am counting how many number of protons is present inside the nucleus, and then I am saying that only 11 protons are present. As I am saying just 11 protons are present, that means it is the sodium element. Right, now I am moving ahead to mass number. Yeah, now I am moving towards mass number. Now, what actually the mass number is? What is a mass number? We studied it. We have been seeing so many times atomic mass of an atom. What is mass number? I'm not speaking about atomic mass. I'm not speaking about mass of an atom. I'm speaking about mass number. So I'm just giving you an example. For example, if I'm taking the oxygen, the atomic number is 8. You have been seeing here some number about the element. About the element, you have been seeing some number for so long, and whenever you have been asking like what is the mass of an oxygen, you have been writing 16 gram or 16 AMU. Like this you have been writing for so long, I know. But what I'm asking is that representing atomic mass? Is this number representing the atomic mass? No. This number is known as mass number. So what is the definition for the mass number? So definition for the mass number is total number of protons and neutrons present inside the nucleus. Present inside the nucleus. Total number of protons and neutrons present inside the nucleus is only known as mass number. So I'm going inside the nucleus. As you can see here, I'm going to enter into the nucleus. Inside the nucleus, I'm going to count the number of protons as well as the number of neutrons. I'm not stopping with counting the number of protons. I'm even going to count the number of electrons. That means even I'm going to count the number of neutrons with the protons, not the electrons. So as you can see here, yeah, this is referring to proton. This symbol referring to neutron. As you can see here 6 proton is present and 6 neutron is present. So what is this atoms? Only 6 proton is present. What is said? Proton, number of protons is going to define an element. Atomic number is the characteristic property of an element. What is the atomic number? The number of protons present inside the nucleus. How many number of protons present inside the nucleus? Only 6. Then what is this element? This element is nothing but the carbon. Yeah, it is a carbon atom which we are speaking about. It is the carbon atom. And what is the atomic number? It is the 6. Now I'm going to write the mass number. How to write the mass number? I should have to calculate the number of neutrons along with the number of protons. I'm going to calculate the mass number. How to calculate the mass number? We should have to calculate the mass number by calculating the number of protons and the number of neutrons present inside the nucleus. That means here it is 6 and it is 6. That means the number is 12. It is a mass number of the carbon atom. and it is the atomic number of the carbon atom. So while writing the atomic number, you should have to write down the atom, write down the element, and while writing the mass number, you should have to write above the element. Now, what is the representation of the mass number? Representation of the mass number is A. It is A. It is a representation, right? It is a symbol which we use to denote the mass number, right? So how to denote an element? How to represent a element? To represent an element, you should have to write like this. Here X is the element. An atomic number you should have to represent with Z, and mass number you should have to represent with A. So it is how you have to denote an element. We should have to write the atomic number, that is number of protons inside the nucleus. Here we should have to count it and write down the element, and while writing the mass number, we should have to count the number of protons along with the number of neutrons, and we should have to write above the element. Yeah. So what I'm going to do is that I'm going to give a common name for all the subatomic particles present inside the nucleus. I'm going to give a common name. Let's see. What I'm going to do is that, as you can see here, the particles present inside the nucleus, whether it is proton or whether it is neutron, I'm going to give a common name. That common name is known as nucleon. Nucleon. Yeah. I'm introducing a new name. Called nucleon. So what is a nuclear? Now I'm going to give you an explanation, a brief explanation on the nucleon. Yeah. So what actually the nucleon is? Yeah, let's see. Let's remove it. Yeah. Nucleon. Nucleon is nothing but, it is the particle present inside the nucleus. Present inside the nucleus. It is a particle present inside the nucleus. The particle may be a proton, the particle may be a neutron. It might be any particle, but we can call those particles as nucleons. So as you can see here, I drawn a diagram. I'm just drawing the same diagram. It is the atom. Here is a small volume at the center named nucleus. As you can see here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. As you can see here, 6 protons and 6 neutrons were present that time. Yeah. Now what I'm going to do is that each and every particle, as you can see here, each and every particle is known as nucleon. Each and every particle is known as nucleon. So, how many nucleons are present inside the nucleus? I said you very clearly, the particle might be proton, the particle might be neutron, but as it is present inside the nucleus, every particle will be known as nucleons. So I'm not going to name as proton, I'm not going to give the name as neutron. As it is present inside the nucleus, I'm giving a specific name called nucleons. Nucleons is a specific name for every particle present inside the nucleus. I'm giving you a new name, nucleon. For every particle present inside the nucleus, it might be proton, it might be neutron, whatever it might be. So, here, the number of nucleons for the carbon atom, how many number of nucleons are present inside the nucleus? As you can see here, the number of nucleons present inside the carbon atom is nothing but 12. As you can see here, number of protons 6 and number of neutrons present inside the nucleus is 6, but the total number of particles present inside the nucleus is 12. That is why total number of nucleons is 12. As you can see, total number of nucleons is nothing but we are getting the total number of nucleons. Total number of nucleons is nothing but the total number of protons and total number of neutrons. So as you can see here, the total number of nucleons, by adding up, I am getting as 12. So whenever I am adding the total number of protons present inside the nucleus and total number of neutrons present inside the nucleus, I am getting the same number as 12. So I can conclude a very good statement that the total number of nucleons is nothing but it is the total number of protons plus total number of neutrons. So I can even say here, while representing here X, here Z is the representation for the atomic number and A is the representation for the mass number. So A is nothing but the total number of nucleons present inside the nucleus. So I am giving you a super duper statement for the mass number. We have two statements. One statement is nothing but the total number of protons and neutrons present inside the nucleus, and one more statement is the total number of nucleons present inside the nucleus. So it is how we are defining the atomic number and we are defining the mass number. It is what we see in today's lecture, and tomorrow lecture it's going to be super duper interesting with a new topics named classification of nuclei. In this we have been going to study isotopes, isobars and isotones.